Hi everybody. Today we are going to see about a hill climbing search in artificial intelligence. This is the example which has been taken from artificial intelligence book authored by Start, Russell and Norwich. So what is this hill climbing search means? It comes under local search algorithms. Local search algorithms are the one which operates using a single current state, okay, rather than the multiple states. It will move only to the neighbors which are maximum or minimum according to the objective function, okay. So what is if the local search algorithms are useful for solving pure optimization problems, in which the aim is to find the best state according to an objective function. Here to explain that, here it is shown a one-dimensional state space landscape in which the elevation corresponds to the objective function and the state space. What in by state space means it has both location, that is the state. So these are all the states, okay. This is state, okay, and it is defined by the value of a heuristic cost of the objective state. Means it is based on the objective function heuristic value, okay. If it is the optimization problem is maximization problem, it has to find the global maximum. If the optimization problem is minimization, it has to find the global minimum, okay. So what do you mean by global maximum means the elevation corresponds, it has to find the global maximum to attain the peak, which is the highest value. Okay, what is the global minimum means to find the valley. If the elevation corresponds to cost, then the aim is to find the lowest value. Okay. So what are the advantage of this local search algorithm means they use little memory because it is maintaining only one single current state. And it often finds a solution reasonably in a very large and continuous state spaces. Okay. So what do you mean by hill climbing search? Okay. It's nothing but it terminates when it reaches a peak when no neighbor has a higher value than that. Okay. So here if you see, so global maximum if it reaches means it is the solution if it is the maximization problem. It can stuck in at 3 points. That is the drawbacks of hill climbing means local maximum, ridges and plateaus. What do you mean by local maxima means? Here if you see, so this is the local maxima. That is why it is local maxima. It is called as local maxima means it is a peak that is higher than each of the current state. It is higher than this point, this point, this point. Okay, this point is greater than these points. If it is the current state means it moves like this and stuck here. Okay, because above that no point is available, but it is actually the global maximum. Okay, so it is higher than each of its neighbors, but lower than the global maxima. Okay, so it is called the local maxima. If it stucks over here, then once again it has to start over. And next drawback where it can stuck means it can be a ridges. What do you mean by ridges means continuously? So I'll show you. So these are all the ridges, okay? So it is a sequence of local maxima. If it is the point over here, then it moves here, then it moves here. It always struck in the sequence of local maxima that is very difficult for greedy algorithms to navigate actually, okay? So here continuously, if it stucks over in the like this, okay, sequence of local maxima will be the drawback of hill climbing search, ridges, local maxima, And next one, it can be a platex. Okay, the platex is nothing but it can be a flat local maxima or a shoulder. Okay, it can be these two kinds. The flat local maxima is the one from which no uphills exist. Shoulder is the one which it can able to make a progress. If it is here, if the current state is here, it moves over here and continuously. What is the flat? What do you mean by flat? Means the current state evaluation function will be the same. Okay, so it's stuck in a flat space from which no uphill exists. Okay, and but in shoulder, another type of platex is a shoulder, in which by moving a continuously, it has to move sideways moves. We'll be calling the best successor has the same value as the current state. Okay, and afterwards, uphill movement will be there, and it can attain the global maximum. Okay. So these are all the things about the hill climbing search. So it is a local search algorithm, okay, and it can find a global maximum or a global minimum according to the objective function. And these are all the three drawbacks where it could not, it be stuck and it cannot find the global highest peak. Okay, that's all. Hope you have understood. Thank you.